Okay, so let me get back to sharing my screen with you, and I will open a blank sheet here, a blank Excel sheet. And what we'll do is we'll try to reconstruct this network interruptions problem, and the number of interruptions. So let's call it network interrupt, the number of them, and we could have 0 to 5 network interruptions. And we had a probability distribution, a discrete probability distribution, giving us the probabilities of having these network interruptions. And if I remember correctly, it was something like this. Okay. I think we had a 0.20 here, 0.10 here, 0.05, and 0.05. So this is our discrete probability distribution. We saw this example in the slides. So what I want to do first is I want to calculate the expected value. Okay, so I can calculate the expected value as, maybe let's first indicate what this is. And I can use the sum product function. Okay, and I can take the number of network interruptions, and each value will be multiplied by the probability, and we got 1.4, the expectation of this discrete probability distribution. So each value is multiplied by the probability, and actually we can also demonstrate it without the sum product function. Okay, taking all those products and then summing it, and we get 1.4, the same thing as the sum product function. So then what we also did, we wanted to find the variance of this distribution. Now we can do this by taking each value, subtracting from that value the mean, and I will need to fix this, and I effectively here calculate the difference from the mean. And what I also need to do is I need to basically square this value. Okay, so what I'm going to do is I'm going to just multiply it with itself. Okay, so taking the difference from the mean and multiplied with itself, just to correct that. Okay. Okay, so if I now want to calculate the variance, now this can be calculated as, again, the sum product of the squared differences from the mean and the probabilities. Okay, and this is the same value which was given on our slides. So if I want to take the standard deviation, basically I need to take the square root of the variance, and that will give me the standard deviation of this probability distribution. Okay, and we could just also play out or simulate the network interruptions let's say over the course of 360 days. And we can try to simulate this and see what happens, what kind of averages or standard deviations we get. So what we can do now to accomplish this is we could simply use the rand function, okay, which there's no input for this function. So it's just rand. And this changes every time we press a key, or we could use the function 9 key to refresh or regenerate these numbers. So what I'm going to do is I'm going to use an if function. And so if this random function between 0 and 1 is between 0 to 0.35, I will assign the value 0 interruptions. If it's between 0.35 and 0.60, I will assign the value 1. 0.60 to 0.80, I will assign the value 2. So I can accomplish this again with an if function. Okay, so if random number generated is less than 0.35, I will assign 0 interruptions. Otherwise, if this is less than 0.60, I will assign 1 interruptions. Otherwise, if this is less than 0.80, I will assign 2 interruptions. Otherwise, if this is less than 0.90, I will assign 3 interruptions. Else, if this is less than 0.95, I will assign 4 interruptions, and else now I don't need to write another function, simply assign 5. And basically I need to close these, and it gives me a color code. So the first one is the random number now changed, as you can see, but it's normal. If you want to fix them, you should just use paste special and values. If you just need to use a specific set of random numbers, that is. So the first random number generated gives me 0 interruptions. Now I want to just go ahead, sort of go down to see, so I can simulate a full year. So let's say we go down to 365 days. Okay. And the numbers will keep changing. So you see 97 gives you 5 interruptions, 61 gives you 2. So it's working correctly. All right. So now in the column K, and what do I have? I have simulated values. Okay. And so one thing that's interesting is to see in these simulated values, how many interruptions do I get as an average? So I can use K colon K just to get all of that. So I got 1.34. And I want to see if what is the actual variance I get and what is the standard deviation I get. And I can actually keep changing these numbers by refreshing the random numbers. So theoretically, I said the average is 1.4, variance is 204, and standard deviations is 1.42. So do I get numbers which are close? Well, pretty much, but now let me just refresh the numbers and see what's happening to those numbers, and they will change, of course. Sometimes they will be above the theoretical value of 1.4, close to 1.4, sometimes below. You can also see the variance and standard deviation are changing, and they're changing above and below the values that we calculated using the theoretical distribution. So we will have more to say on this when we discuss sampling distributions, but this is just a good example of how we could use Excel to simulate, to generate, to use random numbers, rand function, to generate values from a known distribution. One thing I can also do is just to find out in this simulation how many fives, how many zeros do I have. So I want to see if these are close to the probabilities. And for this, I will use the Countif function. Okay. Okay, and I will get the range. Okay, and sorry. Okay, the range will be given. And I want to see if this equals to 0. Okay, so there were 131 randomly generated instances which had 0 network interruptions. Okay, so every time I refresh that, I can also see these numbers are changing. So for example, I refresh it now, and I get different, and the counts are also changing. So one thing that's interesting again, and we will stop this to see this. Maybe that's not what I want to do. Okay, I want to do this. Okay. So this is my theoretical probabilities. Okay, and maybe I could use a different type. Just a standard one. I think this is better. Okay. So the probabilities of observing, and I can change the labels here, change the labels to the correct ones. Okay. So 0 probability of observing 0 network interruptions given here, to 1 interruption given here. So what if I want to also create the same table okay, from my simulation and put them side by side. Okay, and I can also here change my axis labels so they come from 0. So of course this is didn't calculate the frequency or the relative frequency, but it's the same. So if I keep changing it now, you can still see in different simulations, the numbers are changing, but they're pretty much like the theoretical frequencies I have on the left. Okay, so this was a demonstration of calculating expected value, variance, standard deviation from a discrete distribution given here. And also we created a simple simulation using the rand function and the cumulative probabilities to generate a simulated set from these discrete distributions.